All right, whether you're in the classroom this Monday or you decided to watch ET in the gym, you can watch this video and do the accompanying questions, either now during this hour or tonight. And you can have that done, please, by Tuesday, tomorrow. So the last part of 4.1 has us comparing arc lengths. We know that around the unit circle with a radius 1, and if you can see on the screen here, that's the small circle. We know that the x on that diagram will be equal to theta, because on the unit circle, when we're measuring in radians, the circumference, or the distance around our arc, is a portion of the 2 pi, and that relates directly to theta. Now, we say that the angle at theta is subtended by the arc x, and it's also, with the same central angle, subtended by the arc A. You can see that on the diagram. That's the same angle measure. It's just we're looking for the arc length of different circles, I guess. The unit circle's the middle one, and then you can see R labeling the radius of the bigger circle. So if we can look at the top, comparing arc lengths, all arcs that are subtended by an angle will have the same central angle, but will have different arc lengths depending on the radius. And you can see that A is obviously bigger than X, and the radius R is obviously bigger than 1. The arc length is proportional to the radius. So we see if we have a small radius, we would have a small arc length. Because the radius and the arc length, when subtended by the same central angle, are proportional, we can write this proportion, or this ratio. So the ratio of the arc length over the radius will be equal to the subtended angle, this arc length A, over the radius of that circle. And if we solve for A, if we cross multiply here, A times 1 will just be A, and X times R. This formula to finding the arc length works if we're using radians, so not degrees, this has to be radians, and that the radius and the arc length are measured in the same units. Okay, so we see that the arc length equals the x times the radius. We also know that on the unit circle, in radians, the arc length is the same as the angle measure. So we can write this, rewrite this, as the arc length is equal to theta times the radius. That is true, and you can see that little formula there in the gray box right here. So the arc length A equals theta times R if the central angle is in radians, and the arc length and the radius are in the same units. So we're going to do this example here together. You can see, what is the arc length of a circle with a radius of 8.7 centimeters if the subtended central angle is 75 degrees? All right, so we can draw that pretty easily. We have a circle, and this isn't exact, but it's a good one. And we have our initial arm, and from our center, 75 degrees. So let's see here, this is 75 degrees. The question is, what's the arc length of the circle, this measurement of that arc, with a radius of 8.7, okay, 8.7 centimeters. If the subtended central angle is 75 degrees. Okay, step 1, always in these questions, you're going to draw a diagram, which we just did. Step 2, you always need to be in radians. So if it's already in radians, good to go. Otherwise, you're going to need to convert to radians. And this is what we practiced on Friday. And you had that done for Monday's class. So here we have 75 degrees. Full rotation in degrees is 360. And that will be proportional or equal to our angle in radians, that's theta, over a full rotation in radians. We can cross multiply and reduce. When I cross multiply here, I will get 150 pi over 360, which is equal to the angle. And if I reduce that, I would get 5 pi over 12 is the measure of the central angle in radians. All right, let's get some more room here. Then step 3, we're going to use the arc length formula. Arc length formula, which simply says that the arc length is equal to radians times the central angle in radians. And so we can plug that in. We know that the radians is 8.7 centimeters. Of course, our answer will be in centimeters. And then the central angle was 5 pi over 12. Again, that's unitless. So you can see how our answer will be in centimeters. You multiply that out, you use your calculator, and the arc length for this circle with that radius will be 11.39 centimeters. Okay, so with the remaining time today in the classroom, or if you are at home, you're going to finish this assignment, which is at the bottom of the page here. You did the first part up to and including 11 already. That was due today. And now you're working on this. All right, we will see you on Tuesday, and you're to have this at least tried, if not accomplished. Please check your work as you go.